Welcome to our session, Stairway to GitOps, featuring production at Morgan Stanley. I'm Simon Bourassa, Cloud and Infrastructure Engineering Manager at Morgan Stanley, and I'm with
Tiffany Wang. I'm a cloud computing specialist at Morgan Stanley, and believe it or not, after working together for 5 years, this is the first time I'm meeting Simon in person. Very excited.
Nice to finally meet you in person. All right, moving on with our agenda. So, as you can see, the little stairway here, we're going to start navigating you through our journey with GitOps since the beginning. So we're going to start with the early days when we were first, bringing Flux into Morgan Stanley, as well as building our Kubernetes platform. And then that's going to lead us to the first step where our Kubernetes platform and GitOps platform became production. Following that era of time, we got many application owners, cluster owners onboarding different apps to our platforms, and that lead us to very interesting developer feedback. And that's going to be the subject of the third step there. And then we're going to wrap up our presentation talking a bit more about our present day and also possible outcomes and ideas for the future of our platforms. Tiffany, if you want to start with the early days.
Thank you very much, Simone. Oh,
There you go.
that doesn't have animations. Okay. When we started out in our early days, we had a team of platform engineers who were responsible for writing infrastructure as code in order to provision Kubernetes clusters. Once those clusters were stood up, platform workloads at the cluster and platform namespace level were deployed. And these are resources and workloads that cluster owners and application teams have very little to no visibility into. We also had teams of application developers who are responsible for writing application code, defining their manifests, and ultimately deploying their workloads and applications to Kubernetes. This definitely works. Application teams are able to apply manifests from their pipelines, either directly by applying manifests or imperatively by using tools like Helm. And this absolutely works in terms of deploying applications, getting them up and running. But in the event of disruptive cluster operations, things like a cluster rebuild, where the cluster would be torn down, the platform teams would be able to re-provision those clusters in a standardized and reproducible way. But that's not true for the application workloads. Application developers would have to redeploy their workloads because there's no GitOps agent continuously ensuring that desired state is in effect in the cluster. In addition, if there was any configuration introduced, that would have been lost. And overall, there was a large probability that configuration would drift quite widely. On top of that, a lot of our developers were new to Kubernetes, and these were just some challenges that we faced on our journey towards modernization and adoption of industry standards. Sorry, I had a few animations, but they're not showing up, so bear with me. There's a lot on this slide. So we are all familiar with the fact that Flux very neatly addresses that gap in the application deployment story. Flux is able to continuously reconcile your declaratively defined state against your running cluster, and it's also able to continuously detect and correct drift. This solves the problem for cluster rebuilds. Once Flux is installed on the cluster, it's able to redeploy all of the application workloads. However, as any of us in the room working at a regulated enterprise or in similarly regulated industries knows that there's quite the lengthy review process in order to be able to leverage software. So one of the large considerations was authentication and authorization. And 5 years ago, in the very early days of Flux v2, there wasn't support for things like MTLS. So that was something that we needed to solve for and create a solution for. When we started out, we were using a self-hosted Git provider as the source store that Flux reads from. And we needed to ensure that Flux was doing so over MTLS. We also needed to consider Flux's remit and responsibilities, which was determined to be the application layer. And we needed to implement this in a way that didn't encroach on platform workloads and namespaces. So we leveraged Flux's multi-tenancy capabilities built on native Kubernetes role-based access control. And with Flux's service account impersonation, we're able to ensure that Flux reconciling contents on behalf of namespace A does not have sufficient privileges to apply resources to namespace B, even if the app team attempts to define a manifest targeting namespace B. In this way, we're able to ensure that Flux is least privileged, certainly across namespaces, but even within a namespace itself. Right, so now we have Flux that addresses our application's problems or gaps in the application story, but now we need a way to get Flux available to our customers, our app developers. We developed a self-service tooling that allowed cluster owners to install Flux on their clusters in a self-service way, if they so chose. And there's some additional activation energy needed in order to point Flux to incoming application workloads. So we developed some additional tooling. You can see the CMDB platform tooling, which accomplished and made sure that we had the requisite privileges checked on the application developers looking to create the namespace, adding an entry in our configuration management database, as well as our GitOps platform tooling. This was in order for us to enable namespaces for GitOps workflows, which looked like first adding a commit to our platform repository. At CI time, there's a push service that conducts additional entitlements verifications and change control for deployments targeting higher environments before those contents are pushed to the source store that Flux reads from. And Flux prepares that namespace with the icons that you see shaded in blue within that namespace to prime Flux for the incoming application workloads. The other side of our tooling created an application team repository that included the expected repository structure as well as a sample application. And those contents are similarly pushed to the source store that Flux reads from. And this time, Flux is able to deploy the application workloads, which you see signified by the Helm release and the corresponding resources. And this was a mechanism that we used in order to introduce our application teams to Flux custom resources, Kubernetes in general, as well as the way that you're able to declaratively use Helm with Flux. At this point, we had Flux and GitOps enabled in over 50 clusters, and with these tools and with these processes, we were able to make it to production in a compliant way. Now, over to Simone.
Yes. As Tiffany just highlighted, at that point in time, we were finally making both our Kubernetes platform and GitOps platform into production. So that was an amazing team effort and, a great moment for us. And at that time, following that, as cluster owners and our application developers were onboarding their application up to production, a couple of things were up our mind, for the next step of this platform. First of all, GitOps was provisioned as self-service. So for our end users, that was an extra step that they had to do as they were learning GitOps and to onboard it. As well as we were running our self-hosted Git provider solution, which was working great. But looking towards the future, we also needed to have an HADR compliant solution, within Morgan Stanley for this. So we were thinking about how we improve that solution or look at alternatives as a source store. As well as from our end users, we were gathering requirements around having more granular configuration within their namespace where they were deploying different application within the same namespace. And that also led for some other feedback where cluster owners wanted to manage resources among the different tenants because some of the clusters were shared with different tenants. So what we did is actually make our Flux installation through our platform. So from now on, every Kubernetes cluster that would be provisioned with the latest version of our platform would get Flux from day one. So removing one onboarding steps for application owners and cluster owners, as well as for a compliance reason, we decided to move to S3 bucket as our source store to address the high availability requirements. Sorry.
We'll get there.
And then addressing some of the developer feedback and requirements that came in. We work closely to have a common GitOps workflow among the different Kubernetes providers that we're supporting, as well as designing and refining an architecture to address the use case of having multiple apps running within the same namespace. So that came into a solution that was for intra-namespace separation. And for cluster owners that wanted to manage multiple tenants, there's a use case with resource quotas where new tenants gets on the cluster, and we wanted to have from moment zero actually quotas apply. So we leverage our GitOps workflow for these requirements. And I think in this era also one major feedback we were getting from our end users was really about observability. So how to get the Flux status in the easiest manner, as well as their reconciliation status for their different applications. So at that time we worked very closely with our observability team, and we managed to have a central solution around Grafana, where we leverage OSS Flux Grafana dashboard to enhance the observability for our end users. So basically making them like one place to see all clusters, the Flux status, and as well as the reconciliation status of their different applications. And now passing on to Tiffany to talk about GitOps onboarding enhancement.
Thank you very much, Simon. So with the GitOps platform in place and with Flux established as a platform component installed on all clusters, we were able to focus on enhancing the developer experience. And one of the first ways that we sought to accomplish this was by simplifying the number of steps required for users to onboard their namespaces for GitOps workflows. We consolidated and upgraded our GitOps tooling to account for things like entitlements verification, change control for any deployments targeting higher environments, entries in our CMDB, and most importantly, all namespaces are now enabled for GitOps. Now, one of the considerations with the migration from Git repository to bucket is that we were able to solve this at the platform layer, and it was largely transparent to application teams, and they were able to continue using their existing repositories with little to no change. We also developed additional tooling to give users visibility into the source store that Flux reads from for troubleshooting purposes. And with the updated tooling, with the updated simplified workflow, we were able to pare down that bootstrapping component and simplify the onboarding process for our application developers. Now, on the slide, there's quite a few numbers going on, but as you can imagine, with Flux now installed on all of our clusters, with the number of Kubernetes clusters growing, with the number of application teams deploying their applications growing so much, we saw a lot of growth in terms of the number of clusters. We were at over 50, and now we have over 500 clusters, over 2,000 nodes, over 100,000 containers, and tens of thousands of Flux resources. And Flux is responsible for the application layer across all of these. So it became increasingly important for us to focus on cluster performance, as well as cluster resource utilization, but also keep in mind Flux performance and Flux resource utilization. It was really important for us to address these issues that come with scale in a way that did not sacrifice developer experience and introduce undue delays into their deployment workflows. On this slide, you can see some example graphs. So one of the metrics that we needed to focus on was control plane CPU utilization. And on the left-hand side, you can see a control plane in a cluster under sustained high utilization. So we took a look at many cluster metrics, many Flux metrics, and we we worked on tuning our Flux resources, focusing on the Flux layer in order to make adjustments in order to improve the cluster performance, as well as maintain Flux's ability to pick up and reconcile changes as application developers need. Some of the key factors that we looked at were the number of Flux resources, their respective reconciliation intervals, their average reconciliation duration, the Flux max work queue, and we also made updates to the Flux runtime component configuration, updating things like the concurrency of the Flux controllers. And we're happy to say that with the implementation of our tuning efforts, we saw a significant improvement in metrics such as the control node's CPU utilization, introducing additional headroom, and improving cluster performance, while also improving Flux's responsiveness to reconciling and enacting newly pushed changes. Thank you. So one of the things that you might have noticed is missing from our presentation so far is notifications. And that's absolutely something that our developer community definitely wanted to have in place as well. And it was important for us not only to surface this, the success or failure of reconciliations and ultimately application deployments, but to have those be meaningful to our application developers. One of the challenges with having a source store separate to the repositories that application developers interact with on a day-to-day basis is the fact that we need to have a way to represent version source store contents. And we were really excited to see that the Flux maintainers introduced event metadata from object annotations, which allowed us to, thank you, Mateus. With this, we were able to add specific and granular annotations to our Flux resources. We defined alerts for those Flux resources, and the notification controller picked those up, sent them to the provider, and ultimately, we were able to send those notifications back to the pipelines that the application developers use as part of their GitOps workflows. And not only were we showing them the success or failure of their reconciliations and application deployments, but also tied to the exact version that they were looking for. Simon mentioned that we used open source Grafana dashboards for displaying Flux metrics, and that absolutely gives so much visibility into the status of Flux reconciliation, status of health. But we found we needed to tailor those a little more specifically to our application developer community. And so we were able to do that by augmenting Flux metrics, by introducing custom resource state config to kube state metrics, collected in Prometheus, surfaced in Grafana, where we made some updates to those open source dashboards in order to make them the most meaningful and most useful for our application developers. Now, over to Simon to talk about some future considerations.
Thank you, Tiffany. So we're now coming to more present day and also thinking about the future of our platform, thinking about possible outcomes, possible new features or angle we should tackle to improve. One of them is Flux sharding. This is something up our mind to enable Flux configuration per cluster, to accommodate increasing scale for specific end users and customers, as well as right now it's going pretty well with buckets and S3, but we want to take an effort to think about other options as well and make a decision if we want to continue our great journey with S3 or maybe consider OCI as an option, as well as I think Tiffany really highlighted that pretty well, continuing that ongoing engagement with our end users and cluster owners to do that Flux fine-tuning of the different factors that we can control within the tool. And I think something that we also have at heart in this journey so far with GitOps is really the developer experience. So continue to simplify and streamline, yes, the management of Flux, and that could come by leveraging the Flux operator, but as well, and features that were mentioned previously on the presentation, such as resource sets and the granular dependency management. And with all this in mind, thinking forward, Flagger could also be something we want to enable to our communities of developers. And on that note, I want to say thank you to the FluxCon organizers, to Control Plane, and thank you for the audience for listening to our presentation. And Tiffany and I are ready for some questions, and happy to meet you during the conference.
And also wanted to say a big thank you to our team, the teams that we interact with, current and former coworkers, as well as CNCF and Flux maintainers. We're really grateful to be able to stand on the shoulders of such giants. Yeah. And thanks for your patience.
Thank you, everybody, for everything since day one.
I got a cool version. So, any questions for our guests? Monsieur.
You're talking about some of the problems you had with the source, which I know what it is, but can you talk about some of those problems again?
Can you repeat the question if you don't mind, real quick?
Oh.
Yeah, the recording, I think.
Yeah, so he was asking about some additional specificity on some of the challenges with the source store. And can you please specify, like from very early on, or what we see with buckets? Yeah, absolutely. So in order for Flux to meet the rigorous compliance requirements, we had to ensure that Flux was connecting to source stores, and the preferred method was over MTLS. And so I think I can say that we leveraged a sort of sidecar implementation in order to augment Flux controller deployments, so that we could handle the MTLS and satisfy the MTLS requirements, while also keeping Flux without having to go and rewrite source controller code. We were very happy that we were able to do it in an additive way, as opposed to requiring the solution right then and right there. Although I am very happy to say that that is now supported by Flux, and if we were doing it again, we wouldn't have to do it. Thank you for your question.
Yeah, and I think the other configuration I think we mentioned was really HADR for moving to S3.
Any more? Oh, thank you, William, for your support. You are so kind.
Hi. So I was honestly impressed when I saw the scale, the Morgan Stanley, like 500 clusters. That's insane. I can't even imagine that. So my question is, you guys said that you bootstrap the clusters with Flux, right, like built into it. Where are these clusters being deployed? Like, is it on OpenShift? How are you bootstrapping like the CNI or the service mesh for 500 clusters?
Yeah, that's a great question. And I think also in the presentation, Simone mentioned that there are multiple providers. So the answer is kind of all of the above. And Flux is installed on all of the clusters and is responsible for the application layer. So it was really important for us to maintain a common workflow at the application deployment layer. So you can imagine customers deploying something on-premise, something to public cloud, something, to maintain a similar workflow is really important for us, and something that we're, continuously working on aligning. So, yeah, thank you for your question.
Thank you.
We have time for one more.
Yeah, he was first.
I don't know how well we are on schedule. It's awesome.
Something you guys said in your presentation was that you made the switch from using the Git repository as a source of truth to an S3 bucket, and that was transparent to the users. How did you do that?
Yeah.
It takes, especially if you're publishing, OCI images to an S3 bucket, like that would take time. There's going to be more latency. How did you do this?
Yeah, so a lot of the consideration happens at CI time. And I mentioned that there's a push service that we were able to, make the large part of the even that wasn't that much of an update. From the platform layer, the biggest consideration, if you think about it, is really the paths on customizations, as well as the source ref, and making sure that the contents get to the expected location. And so by doing things sort of under the covers and making updates to the tooling that our developer community uses, we were able to, with very minimal changes, sometimes no changes needed from the application developer side. And that's something, as Simone mentioned, we are continuously looking to streamline the developer experience. So as we make changes that could have, drastic impact on developers, introducing a whole lot of migration steps, we are constantly thinking about ways that we can mitigate that from the platform level and enact it in sort of a widespread but controlled manner.
And
I
just
think,
one minor detail we can add is also we were using some of our platform versioning to do that migration also. That was another little lever to use and kind of force people to move forward.
Yeah, we can make time for one more because there's a lot of interest here, so I don't want to break the flow.
Thank you. First off, I just want to say I love Flux. And second off, how do you manage developer education on writing good customizations? If you're saying that people are supposed to write their own manifests in their own repository to deploy via Flux, a common theme that I hear across a lot of other people is that they use Flux for cluster bootstrap and things like Argo CD to actually get the applications out because there's zero config needed. But like we use Flux a lot, and a common problem that we run into is people don't adhere to this idea that tenants or namespace, for example, have to go in a separate customization to avoid race conditions, and they're gonna put different things across different places, and things fail for like 10 minutes or something. And like I'm on a platform team, and we manage all the clusters, and I get questions like, "Hey, my thing is not working." So how is it that you manage this problem by telling developers on how to intelligently write customizations?
That is a really great question, and I think that is, maybe for all of us, a continuous work in progress. We definitely write a lot of documentation on top of, pointing to Flux documentation, as well as, giving users examples. And we also make some decisions at the platform layer, things like a few configurations for customizations. When it comes to, perhaps something specific to a team, we ask that they learn out loud and they ask their questions in the open, and we have, questions that we post answers to and, share that knowledge. Can I say in Stack? Or
We build our internal community.
yeah, we build and sort of nurture our internal community, and that's something that like I said, we're continuously working on. And
Yeah, I would just summarize it as it's kind of a big part of our journey. So it's not like just a technical solution. It's just been part of the culture we tried building around Flux and GitOps like in the last maybe 5 years or so. So, yeah, that's the solution. Sorry. Yes.
thank you very much for your question.
Thank you once again. Thanks so much. I'll take this one.
Thank you so much.